Alright, so now we're on Objective 1B, the second part of Objective 1, where we are working with quadratic functions when they are in intercept form, as you can see in this picture. This picture is pretty excellent. It's a picture of a bouncing little basketball, and it was taken at 25 frames per second, and then all composited together. And you can see that it makes a shape, traces out a shape of a parabola. And if you notice, the 2 points that are highlighted here are the two x-intercepts, which is why this thing is called the x-intercept form. Well, the intercept form. So, let's take a look back at Geometry Sketchpad, do a little investigate what the parameters are on the intercept form of this equation. Alright, here's one more form. This next form is called intercept form. Let's see if you can figure out why. So I put this one as I of x equals a times, and it's factored. It's in factored form here, x minus p times x minus q. A, well, it's like skinnier, fatter, reflection. A is always the same. Okay, now let's change p here. My p is at 3. Yeah, it did move it, but is there a 3 associated with that graph? 1, 2, 3. Yeah, it's right there. That's interesting. Let me move this one. A 2. Is there a 2 associated with that graph? Why, certainly. It's right there. What are these things? Move it someplace else. So this one's at -1, that one's at 3. -1 and 3. Those things are the x-intercepts, which is why it's called the intercept form. So specifically, x-intercepts. So here's another question. Like the previous form, the vertex form gave us the coordinates of the vertex. This one doesn't. So what could I do in order to get the vertex pretty easily? How about the same thing that we did to come up with the formula for the vertex to begin with, which was if I make myself a segment between those two x-intercepts, and then I find the midpoint, there we go, and then I just construct myself a perpendicular line between those two things, construct perpendicular line. What kind of line did I just create? The axis of symmetry. And its x value will be the same x value as where it is at the vertex. So in order to find the coordinates of the vertex, if it's in intercept form, you just average your two x-intercepts. In the equation, it's averaging the p and the q. Alright, so now we're looking at a quadratic function in intercept form. It looks like this. Y is equal to a times x minus p times x minus q, where the p and the q are the x-intercepts. Those 2 points right there. Okay. The a value is the same a value when it's in standard form, when it's in vertex form, and when it's in intercept form. So it does all the same things. Tells you if you got yourself a beard or a mustache. Tells you whether it's going to be a fat one or a skinny one. Okay? If I wanted to find the coordinates of the vertex, I want to take the average of the two x-intercepts. Take the average of them, p plus q divided by 2. That's going to give me my x coordinate, which is also the equation for the axis of symmetry. If I wanted the y coordinate, of course, I would just plug that back into the equation so that I could find it. So, here's a question for you. What is the y-intercept of the graph of, now we just have the general intercept form of that equation. So it's not like standard where we could just pick it out, where it was just the c value. Now, I got to do a little bit of algebra. Remind me again, what is x equal to if we're talking about a y-intercept? So it's on the y-axis. Any point that's on the y-axis is 0. So x equals 0. So I'm just plugging zeros in for these x's. Y is equal to a times 0 minus p times 0 minus q. And then simplify it. So for the first set of parentheses, I have a negative p, and the second one a negative q. A negative times a negative is going to make this positive, so it's a times p times q. There is the y-intercept. Piece of cake. Again, it's not a formula you need to memorize, it's just this is the process that you'd have to go through whenever p and q are some sort of numbers in the equation you were given. So now let's graph them. So here are the steps involved in graphing a quadratic function when it's in intercept form. So first take a look at that a value and determine whether it is going to be a beard or a mustache. A beard if it's positive and mustache if it's negative. The p and the q, those are already your x-intercepts, so on number 2, go ahead and graph your x-intercepts. You might go ahead on that step also and plot your y-intercept, and that's just plugging 0 in for x. Number 3, you're going to find the vertex. How do you find the vertex? Well, it's halfway in between your two x-intercepts. So average those out, and you'll get the x-coordinate, plug it back into the equation, and you can get your y-coordinate. Graph the axis of symmetry, so you already got the equation of it whenever you average the x-intercepts. And then finally, if you need to, number 5, just plot a couple of extra points and their reflection across the axis of symmetry. So let's try one of these. Graph negative x times x minus 4. It's in this kind of factored form, and I want to recognize that factored form as intercept form. So step 1 is this thing a beard or a mustache? So since it is negative out here, this means it's going to be upside down, wearing a mustache. Okay. Now, what did I need to do next? I need to find my two x-intercepts. So what do we do whenever this x is all by itself right there? Well, that's just like it was x minus 0 equals 0. And that just means x is equal to 0. So anytime you have this x all by itself, no plus or minus after it, that automatically means the origin is one of your x-intercepts. Alright, now for the second one, x minus 4 equals 0, so x is 4. Of course, I don't have to do all this little math for it. I can just look at it and just change the sign. Right? Of course. So I'm going to plot those 2 points at the origin, at 4. Next, I need to find, how about the y-intercept? Well, don't I already have it? I do, because if the origin is an x-intercept, it has to also be a y-intercept because it's on the y-axis too. Okay, so next, let's find the coordinates of the vertex. So to find the vertex, I'm just going to average out these two x-intercepts. So x is equal to 0 plus 4 divided by 2, which is 2. There is the axis of symmetries, x equals 2. I'll put that as AOS. Alright, and then for the vertex, the y-coordinate of it, I'm going to put that back into the equation. So y equals negative 2 times 2 minus 4. In parentheses, I get a negative 2, so negative times negative makes that positive 4. My vertex is at 2, 4. Go ahead and plot that point. And its axis of symmetry, 2, 4. Now, 3 points, maybe I want a couple of extra points. So what I will point out to you is, since essentially your a value here, your a value here is a 1, it's actually a negative 1. You're not getting any fatter or skinnier from the parent function. So this is the same width as y equals x squared, the parent function, which means you could redraw the parent function right where you're at. So here is an example. For example, 1 squared would be 1, negative 1 squared would be 1. And then that's enough to graph the rest of your parabola like so. All right, not too bad, not too bad. Way, way easier than the standard form, in my opinion. So here's one for you to try in intercept form. Y equals 2 times x plus 1 times x minus 4. Grab some graph paper and start graphing. Pause, you try it yourself, and then come back and see if you did it right. And here's the algebra side of your work on graphing this equation while it's in intercept form. So first I want to check out that 2 there. It's positive, which means this parabola is wearing a beard. And then since it's in intercept form, the next easiest thing to do is determine what the x-intercepts are. So just change the signs of the numbers that are inside the parentheses. Negative 1, positive 4, graph them. Alright, I do find the y-intercept next, but that's not what's next on my graph. What did I pretend that didn't happen yet. Anyway, so then I'd find my vertex. I find my vertex by averaging out the negative 1 and the 4. I do get 3/2 or 1.5. It's a fraction. No, I'm not sorry. Sometimes fractions are unavoidable, so get used to them. Anyway, so plug it back into the equation. Find your y-coordinate, you get negative 12.5. Now I'll go ahead and graph that thing. Okay, that's not really enough to graph my parabola, so maybe get another set of points here. And that's where that negative 8 for the y-intercept comes in and reflected across the axis of symmetry. So on this one, it is 1.5 to the left, so let's make it 1.5 to the right. There's enough to make our glorious parabola. Okay, in conclusion, we are just graphing some quadratic functions when they are in intercept form. Y equals a times x minus p times x minus q, or p and q are just our x-intercepts. Pretty easy to graph, not too painful, and certainly less painful than the standard form. Oh, and before that, we were doing graphing of quadratic functions when it's in vertex form. Y equals a times x minus h squared plus k, and the h and the k were the vertex point, and then you could just use SRT transformations on it. Yeah, you remember. Anyway, see you in the next video.